Hey guys, welcome to another online math class. This video will be our last lesson on linear graphs and will be about piecewise linear graphs. So by the end of this lesson, we should know what a piecewise graph is, be able to determine where a graph starts and ends, and also be able to construct a piecewise linear graph. Let's just pause the video here and take a couple of minutes to write these down. So in some situations, you'll require two or more linear graphs to obtain a suitable model, and these graphs are called piecewise linear graphs. And some examples on the right here, these are what they might look like. On the bottom, that's just two linear graphs. And over here, I've got 1, 2, 3, 4 linear graphs combined. So they're called piecewise linear graphs because they're pretty much little pieces of different linear graphs. So that's what they are. Let's have a go at solving an example question. So this question says that the amount $C charged to supply and deliver X meter cubed of crushed rock is given by the equations as shown there. And our second goal was to be able to determine where a graph starts and ends. So we need to know where these two graphs start and end. So this first graph here starts at when x equals 0 and goes until when x is smaller than 3. So it doesn't go until 3, it goes until it's smaller than 3. This one starts when x equals 3 and goes until it is just before 8, so smaller than 8. So we need to be able to read those there. And now let's have a go at question A here. It says use the appropriate equation to determine the cost to supply and deliver the following amounts of crushed rock. So this first one is 2.5 meters cubed, and to determine which graph or equation I would use, I'll look at the ranges there. So 2.5 meter cubed is in between 0 and 3, so I would need to use that first equation there. So once I've determined which equation to use, I'm just going to substitute the value into there. So C is the amount it costs, and x is the meters cubed it is, so I'm going to replace x with 2.5 there. So it's going to be c equals 50 plus 40 times 2.5. So that's how I would solve that. Once you've got that, just put those values into your calculator. So that is what your count should look like at this point. Just press enter and you get 150. So your answer for the first one will be $150. Alright, now A part 2, let's have a go at that one. I'll do that one down here. So for this one, it's 3 meters cubed. So remember, this one doesn't include 3, it's just before it's 3, so x has to be smaller than 3. This second one includes 3, so I'm going to have to use that second equation, c equals 80 plus 30x. So once I've got that, I'm going to replace x with 3. So it's going to look like this. And then you can chuck that into your calculator or solve it by hand, that's up to you. 80 plus 90 gives me 170. So C, it's going to cost $170 to supply and deliver 3 meters cubed of crushed rock. And part 3, this one is also the second equation. 6 is in between 3 and 8. So I'll just chuck that into that formula. C equals 80 plus 30 bracket 6. So C is going to equal 80 plus 180. And 80 plus 180 gives me 260. So it's going to cost $260 to deliver and supply 6 meters cubed of crushed rock. And question B says use these equations to construct a piecewise linear graph for those values there. So once again, starting off by drawing the axes. So I don't need negatives here. I don't have any negative values. So I've got C going up because that takes the Y position for mx plus C. And that means going across will have to be the meters cubed there. So I'll just replace that with x. And making sure you go a bit further there and label that as the origin. Alright, so the first part of my graph is going to be this one here, because that starts at 0 and ends just before 3. So that means my y-intercept here is going to be 50. So I'll replace that there. I'll actually draw that in. That's going to be 0, 50. That's my first position. So the starting point of that first graph is 0, 50. X is 0 whilst y is 50. And I also need to determine the end point of that. So this graph ends at 3 or just before 3. So I'm going to replace that x with 3 there. So it's going to be c equals 50 plus 40 times 3. That becomes 50 plus 120, which equals 170. So it ends at 3, 170. Once I've got that, I can just plot that in. I'll say that's about 1, that's 2, that's 3, that's 50, that's 100, that's 150. So I could say that's about here. So I'm going to draw a line to connect those 2 points. Don't go beyond that because that's where it ends. So that's the first part of my piecewise graph. So you need to find the start and end positions of that graph. So I need to do that exact same thing with this second equation there. So this graph starts when x equals 3, the second one here. So I need to substitute 3 into that second equation. So it's going to be c equals 80 plus 30 times 3. That becomes c equals 80 plus 90. So c equals 170. So the start position, I'll just write that down the bottom there. So start would be 3, 170. And that's just, we'll just plot that in. And that's just going to be where the first graph ends. And now to find the end position, I'll just write end at the bottom and we'll fill that in after we've done the working out. So it ends when x equals 8. So let's write that in. C equals 80 plus 30. Replace the x with 8. So C is going to equal 80 plus 240. C equals 320. So my end position is 8, 3, 20 there. Alright, so I'm going to plot that in. Let's say 8 somewhere around here. It doesn't have to be completely accurate. And then I've got, let's say 320 somewhere around there. So once you've got those two, connect those two lines and make sure you label the points. That's 8, 320. This one is going to be 3, 170. And I've already labeled that one as 0, 50. So that down on the bottom right is what my piecewise linear graph would look like. So that's the steps involved in making one of these. Alright, so that brings us to the end of this video. Thank you guys for watching and I'll see you guys all back online.